I'm Zar. I'm sort of a resident speaker on this meetup, and we started just May last year, exactly a year ago, as an online-only event in the middle of COVID. And unfortunately, we had to go to online event this time as well. I recently joined Google Developer Experts program. Yeah, and I love my job. Thanks for DoiT for sponsoring my time to prepare this talk. And to make it more interactive and for the audience, I invite you to fetch up your phones and scan this QR code so you can ask questions in real time. And our Q&A session at the end will be based on that. We also have some polls to collect feedback in real time during the presentation. So again, please be active, please submit feedback, and let's go with it. So first, I'd like to understand the baseline of the Kubernetes knowledge within the audience. It will help me to focus or skip certain sections to not waste everyone's time explaining things that you already know. So please, again, if you can use QR code, and let's just give 10-15 seconds to reply. Oh, some results coming in. Thank you. Thank you. Any more responses? Okay, 3. Let's see if we get 5. Give it another 10 seconds. 7 seconds, 5 seconds. Oh, 4 responses. Okay, one more. 3 seconds. Thank you. Okay, so I guess some people are quite familiar. Okay, 7. Okay, 10 maybe. Okay. Okay, so we have a fair thread. Thank you very much for that. We have a fair thread of technology. So, okay, so I'll do a quick run about why Kubernetes and what it provides, so we can have a baseline, everyone on the same page. Okay, so for me personally, Kubernetes is about uniform application development. So if we fast forward 10 years ago, right? 2011, we have already AWS with all the basic services like compute, persistent storage, databases, object storage, and you want to develop a new application. So what do? You have an application, you wrote some code, you want it to be scalable, so you have several processes talking to each other. So now I have to think, okay, how do I package this application? Would I use Debian packages? Would I use RPMs? Would I just copy binaries? And I need to deploy to VMs. Where do I take VMs from? I'll probably go to some infrastructure as a service. But then again, I need to think which operating system, how do I keep it up to date? How do I configure it the way I like with all the dependencies that my application requires? And then I need to think, okay, it's probably going to be one application per VM, which will cause underutilization. Because otherwise, if they're on multiple apps on single VM, they can clash and be noisy neighbors and step on each other's toes, resources-wise. Now, let's say I figured all that out and I deployed it, and I don't need to develop some practices to make sure it still runs. And eventually, when I have this unit of work, I need to scale it, and eventually have a big zoo of VMs, which I need to monitor to make sure it all runs. Now, for each arrow here, there's plenty of off-the-shelf technologies that allow doing that. So it's not like you need to completely write everything from scratch and reinvent the wheel, but the choices, there's lots of choices, like handful choices for each arrow, and eventually you'll end up with your own collection of tools that leads to a great job security to your DevOps team. But then, this joke aside, assuming you have a new person coming onto your team, you need to upskill them on your particular choice of technology in every stage of the project, and it's not simple. So it's hard to upskill new members, and every company is doing something of its own, right? So Another poll, please. Those who freshly joined, please use the QR codes. I'm curious if you have experience running applications again at pre-Kubernetes era, sorry, what I call the hard way. And how do you find it? Thank you to all those who participate. Some people actually enjoyed it. Yeah, I enjoyed it too 10 years ago, but yeah, there was no other choice. Let's give a couple more seconds. Really curious. Okay, it looks like general consensus that it's mainly people either find it hard or luckily avoided it. Thanks again for voting. And now this is where Kubernetes came. So for me, when I switched to like a new project in 2015, I thought, okay, I did it the hard way. Are there any better choices? And Kubernetes was just unfolding to 1.0. And it was like, wow, actually someone thought about all these problems that I had and created best practices and even implemented the technology that we can now just follow the blueprint and let's think on choosing tools and have a unified approach. So if we traverse the similar diagram through Kubernetes way, we still have an app, and then we have a blessed way to package it. We package it in what's called the Docker image, which gives us reproducible build, and then we can run that image anywhere. We can run it on a laptop, we can run it in the cloud, in what's called container, which is like an isolated process, and we can have now several processes on a VM, which improves our resource utilization. And in Kubernetes, we wrap this context of container in what we call pod, and Kubernetes takes care of keeping it up and running. So we don't need to think about those tools either. And then we can scale this thing. We can have multiple pods, and then we have process A wants to talk to process B. All they need to know is a generic IP or DNS name of the other process, and then it just can talk to each other without thinking which process exactly is on the other side and how to locate it and who takes care of its being up and running. To continue, I'll create a couple of clusters because they take some time to create. So I'll create 2 clusters. In GCP, you can have a standard and autopilot cluster. So I'll create 1 standard and 1 autopilot. There's plenty of options here to choose from, but I'll just stick with defaults. And I'll have another one that's called Autopilot. I'm creating them in separate project because we'll mainly be looking at the Autopilot one during this session. Okay, so it's Autopilot. It's much simpler. You basically provide just a name and the location, and yeah, give me a cluster. Right, so yep, this is the Kubernetes way. And again, what it gives us is we don't need to think too hard. We just have a technology where which we can use to define how our application runs and how components of our application find and communicate, and many, many other things along the way. But this is like the baseline to understand the Kubernetes. Still, where does it run? So we have a language, but eventually it needs to be executed somewhere. We still need compute, we still need RAM. So of course, cloud providers step up and say, yeah, we'll manage Kubernetes for you. So we'll basically run the VMs, we'll install Kubernetes on them. So when you launch your application, it will be hosted on our VMs, right? And the first of Google were the first to host Kubernetes. I think 2015 they released 1.0 of Google Kubernetes engine. And they said, okay, we already have our compute engine, so they basically use VMs to be Kubernetes nodes, and we pack them into pools, and we call these pools node pools. And they naturally map to compute engine instance groups, and instance groups already know how to do things like auto-scaling and healing in case a VM crashes. They have like templates, they know how to replace a VM. So it mapped up nicely. And they say, this is what we charge you for. So for all of the service that for all the hours that we do to run the cluster, we'll charge a control plane fee of $73 a month per cluster. They usually put prices in the hours, but our brains are not good at distinguishing difference between 3 and 5 cents per hour. But when you that's why I like to show prices per month. So when you think, okay, this is my NBN bill. Okay, that makes sense. So again, there's a control plane fee, and then you just pay for VMs that you use. The more VMs you launch to join your cluster, the more you pay, and you pay the same list price that you'd have paid if you used the VMs directly. So all the other things like sustained usage discounts, committed usage discounts apply. You can use preemptible VMs as well. All good. So let's see if our cluster is already up. No, not yet. So we see it launched us. Probably should have started a bit earlier. So it launches us 9 nodes, 3 nodes in each region. Okay, so the thing is, now we launch, and I'll show it in a demo. The thing is that we launch VMs, and then we deploy our containers on the VMs. The problem is that it's kind of a fine art to make sure your VMs are packed enough with containers, so you keep it efficient build-wise, but not too packed, so you get performance issues. If your workloads are static, it's pretty easy, but if your workloads are dynamic, you usually have some spare capacity, and then people start to come with requests. Let us provision VMs, on demand, and Google and GKE team developed features like Node Auto Provisioner, where you can create both nodes and new node pools on the fly. It can scale almost to 0, but again, it requires more Kubernetes and GKE specific knowledge to run and maintain. Okay, so our cluster is up. So we can see it's a standard cluster. We can see all the nodes that belong to this cluster. This is our long list, and VMs are here. So again, this is GKE Standard. They basically give us a good wrapper above the VM layer, but we can still see the VMs themselves, right? We have full control of the VMs. We have root access. We can SSH to them, and we can even kill them if we like. Something is very slow here. Wow. Yeah, so these are my VMs. I can see them in Compute Engine, and again, I can do with them whatever I want. Of course, if I delete one, sorry, my things are slow here for some reason. Yeah, of course, Google will GCP will recreate a VM if I'll kill it. And once I have the cluster, I can deploy things. So if I go back to clusters, I can now have a workload session. I can just say, let's deploy container, and let's say I want just to deploy Nginx. So there's like an image, pre-built Docker image here that I select, and eventually it shows me the definition file. So everything in Kubernetes is built on YAML file definitions. Okay, I won't launch this. I created one earlier here. So let me fetch credentials. Okay, so this is my simple definition. All it says, I want to run Nginx server. I want 3 replicas of that process. And now all I do is kubectl apply, give it the file, and it's created. Now, the cool thing about it is nothing here says GCP or any other cloud provider. So you can take this YAML file and you can launch it anywhere. You can run Kubernetes on your laptop. You can run it on Amazon distribution of Kubernetes, GCP, wherever there is a Kubernetes. You can actually take your application and launch it anywhere. And you define lots of things here, right? So you define the version of your software. You define number of processes, and on and on and on. And this is kind of portable application setup, which you can take wherever you want to. And this is a big thing. If we go back to workloads, we can now see our workload should appear soon. Yep, here it is. And GCP provides us with a nice UI. So we can have logs, we have events, and we have all the metrics here, right? Even things like memory and disk usage, things that you don't get, things that you won't get from VM unless you install agents. So GKE is already instrumented to provide you with all those things, right? And we can see all the details. We can see the names of our 3 processes, and we can click and see where they're on, right? So this is GKE Standard in the nutshell. Now, still, we have those VMs, and we need to think like GCP does the automation for VMs, but VMs still in the picture. So we need to think what VM size is good for us. Should we use in 1 VM? Should we use in 2 VMs? Should we use E2 VMs? How many node pools we need? What sizes? It's how to what extent are they utilized? And there, I think it would have been from long-term Kubernetes user. I think it would have been great if you could just say, these are my application specs. Every pod says how much RAM and CPU it needs. Maybe we'll just give it to some magic infrastructure, and that infrastructure will provision enough resources, compute and RAM, and just run our pods and give us a break with all this VM stuff. Funny enough, when I first saw Kubernetes 6 years ago, I thought that's what GCP would provide. And of course, it wasn't the case, but you see 6 years forward, we are getting there. And this is what Autopilot project does. So you don't see Kubernetes nodes at all. They VMs, I mean, you don't see VMs. They're hidden from you. And since they're hidden, your payment, your billing model is different. You're still being charged for the control plane, the same $73 per month. But instead of paying for VMs, as with GKE Standard, you pay for the resources that your pod requests. Okay, so let's say you launch Nginx and you say, my Nginx needs 1 CPU and 1 GB of RAM, and it runs all the time. So Autopilot will charge you $32 per CPU and $33.6 RAM per month. And that's a lot, right? For $32 a month, you can have like a couple CPU and 2-3 gigs of RAM VM easily, right? So if you have a static workload, definitely Autopilot is not the cheapest way for you. But if you have highly dynamic workload, if your resources come and go, then it makes sense, because you can experiment freely. You don't need to think about configuring your node auto scaling features and make sure they work and make sure they not break. You know that you pay only for what you launched, and this is something you easily control, in your mental model. Okay, this is I developed, this is this thing I launched, and this is what I pay for. You don't need to think about the infrastructure behind it. So let's see in details how it works and try to infer how GKE do things behind the scenes. So this is our Autopilot cluster. If I click it, there's no nodes here. This tab is absent. So if I go to workloads, don't have any workloads. But then let's try use kubectl and see if you can infer things on how things look behind the scenes. Let's fetch the credentials. Okay, so let's get some pods. There's no pods running, so I didn't launch any processes here. But definitely should be some nodes. Though we don't see any GKE VMs because they're hidden, we should see some nodes through the Kubernetes API. And yeah, we do. So basically, yeah, we see nothing through the UI, but if we go through Kubernetes API, we can see that we have a couple of nodes ready. Here we can infer their Kubernetes version. And if we do describe on them, we'll actually see what kind of machines do they run, right? So we can see here on the labels that they use E2 machines, medium, which means they have 2 CPUs and 4 gigabytes of RAM, and they all utilize to run internal system Kubernetes pods, right? So kind of this is a sneak peek on what's going with GKE Autopilot behind the scenes. So let's deploy a workload. I prepared the tiny version of Nginx. Oops. Yeah, it is. So basically I'm saying, please deploy a pod from this image, kind of CLI version of what I've done through the console before. And I want to say, this is a very unfussy workload. It uses very little CPU and very little memory. So now we can get our pods. We see it has container creating because we had some spare capacity on those 2 nodes that are deployed, and hence it fit on the VMs that GKE Autopilot had behind the scenes. Again, this is completely transparent to us as an Autopilot user, but I'm just trying to explain the logic of what's going on behind the scenes. And if you run it again, probably should be running already. Nice. So if we now describe our nodes again, we'll see on which node did it land. Here's our Nginx Tiny. Now you may notice that it says this pod has 20 quarter CPU and half a gig of RAM, though we requested 50 milli cores and 64 gigs of RAM. So the thing is that with Autopilot, there is a minimum workload size that you can run, and they require you, and that say you can't provision less than quarter CPU and half a gig of RAM, and they will bill you for that amount. So basically, if you take my previous pricing and do the calculations, so 24/7 pod will cost you at minimum $10 a month for quarter CPU and half gigs of RAM. And if you'll take the pod and we'll see its definition, we'll see here that the admission controller that makes sure that we don't provision too little resources, it actually injected those resource definitions and says, okay, you requested 50 million CPUs, but no, I'll set you to 250 because this is how it was designed. And they actually define limits as well. So one of the strategies with Kubernetes, you define the minimum required resources, but you don't define the hard limit, right? And then if your workload needs to burst and the node CPU is not too busy, then it can actually burst. With Autopilot, they don't allow that. So both requests and limits are defined. So quarter CPU is what you get, and that's it. Now, we can now get rid of this pod. And by the way, of course, if we refresh, we'll see it in our workloads. And we'll get all the same bells and whistles of GCP console with regards to monitoring and logs and events, etc. So now I want to show you the difference where the Autopilot takes care of the VMs, but it doesn't take care of scaling your application. You have to tackle for it yourself. So let's delete our tiny Nginx. Right, and I want to look at more beefy workload that I want to define here. So I created another YAML definition. So first, I say I'm running Nginx server, and I'm using open-rested distribution of Nginx server, which is basically Nginx with Lua programming module enabled. And I'm injecting into this container a config file. And the great thing about Kubernetes is they can actually define config files as part of Kubernetes itself. So here I have what I call a config map, where I define the whole Nginx configuration from scratch, and I inject it into container. So my configuration is quite straightforward. I say I want 4 worker processes handling up to 1,000 connections each, and everyone who goes on root of port 80 will have Lua script executed that will calculate 50 million random numbers and report on completion. And this is all my web server does. Of course, it does require quite a bit of CPU. So on my resources, I'm provisioning 2 complete cores for this workload and half gig of RAM. And I want 1 replica of this thing. Now, to be able to run some workload tests on this, I define another thing called service, which provides that unified DNS endpoint for that for the group of my processes. And I also asking to provision a load balancer with external IP so I can connect to this thing with my load tool. And again, there was nothing there that said GCP or AWS or any cloud provider. That's generic. And all I need to do is run kubectl apply, give it a file, and it goes, reads the file, and creates Kubernetes objects, and my workload is being created. So I can run some watch command. Now, if you remember, I requested two complete cores provided to this workload. And these nodes are quite tiny, right? They only have 2 CPUs each, and they're already used by other workloads. So what Autopilot is going to do here is going to automatically provision a new node, a fresh new node, where it can place my pod. So it will take, about a minute. We should see it soon. Again, all I did, I went to the UI console, launched the cluster, and I didn't configure any auto scaling for the nodes, VMs, anything like that. Just created a cluster. Okay, so we have our workload that we launched. It's pending. And we should see a fresh node coming up soon. Oh, okay, cool. So you see new node appeared. If you're familiar with GKE naming convention, you'll realize that they created a separate node pool. It's a fresh one. We can actually now select this node and describe it and see what size it is and what did they use to what family did they use to run it. So again, judging by the labels, because I don't have this information on the console itself, we can see that it used E2 high CPU 4, which basically means we have 4 cores and 4 gigas of RAM. So okay, it applied some heuristic, decided this is the best suitable node in the current situation. It's not my concern from as a user, as a developer, because again, I only pay for the pods. And this node is ready, and my workload is running. Now I can fetch the service definition. Here is my external IP that was provisioned, and then now I can curl it, and I have done crunching. That's the message that says we've just completed computation of 50 million random numbers. Now, time for load testing. In the same project, I have another VM called WRK. This is the tool that I use for load testing. And I can point this tool to open 1,000 connections with 5 threads each to start bashing hard my Nginx server. So let's leave it running. And if we go to workloads, we'll soon see that usage here is going to spike. So you see, this is like the upper limit. This is the amount CPU that we provisioned. Stack driver is a bit slow to update. It takes a minute. But after a minute, we'll see that the usage will go up to 2 and will stuck there. And this is like the main difference between Autopilot and, let's say, serverless framework, because serverless frameworks, they usually provision resource dynamically as much as required to accommodate the load. And Autopilot doesn't do that. It only provisions VMs for the pods that you requested. So if you want to scale, it's up to you to scale to have more pods, and then Autopilot will take care to provision VMs for those pods. We now see that load is starting to climb up here. Thankfully, there are Kubernetes native ways where, again, we can, in vendor agnostic manner, describe that we want our workload react to the load. Okay, and the most simplest way to do that is based on CPU usage. So I defined what's called a horizontal pod autoscaler in very simplest form. First, I give it a target. I say, look at Nginx workload that I've just created, and I tell it you can scale it between 1 to 20 replicas. So if needed, you can ramp it up to 20 processes. You know, again, 2 CPU cores each, so up to 40 cores. And I allow it to run, you know, to react quite aggressively, and say you can launch up to 5 new replicas every 10 seconds, because for sake of the demo, I want it to be more like dynamic. And again, to make it more dynamic, I'm saying launch enough replicas till average utilization for every replica, every Nginx process will be just 20%, which will never reach because we're banging with 5,000 connections. But we'll see how the system reacts to this auto-scaling thing. So all we need to do again is kubectl apply, and the file, again, this is Kubernetes native thing. We don't have any cloud provider specific definitions here, and you just can take that YAML again and launch it on any Kubernetes cluster. Going back to our watch thing, we have now new member here, which is Autoscaler, right? And Autoscaler recognized that our deployment is heavily overutilized. It's 100% utilized instead of 20 that we want. And it decides to ramp up another four replicas. Now, you see the pending again. Why? Because the fresh node that we recently have here has 4 CPUs, right? Let's look at it again. It has 4 CPUs that actually, you see, it utilized 59%. So 51% is our workload, which takes 2 cores plus some system cores, a bit of a system workloads, just above half, and we need another 2 full cores to place a new workload. So from this perspective, we see it's quite a waste. We basically have this node utilized only 60%, and we'll have to launch a new one. Again, we're not paying for that. This is like Google's problem. But I like to demo here how the system behaves, so you can what to expect from it. You see we have 4 fresh nodes starting up. So Autopilot decided not to outsmart itself and just launch another four nodes. I can see they sit on the same node pool, so they are all of the same type, and they are still those similar nodes of 4 cores and 4 gigabytes of RAM. So all it will be able to do is just to put one pod on each node. And again, we'll have now 5 nodes that are utilized only 60%. But again, we only pay for the pods and not for the nodes themselves. We still on 100% load instead of 20 desired. So within 10 seconds, we should have more replicas here and more nodes launching. Okay, you see we have fresh copies, another 5. Remember I said you can launch up to 5 every 10 seconds, and then added 5 more copies. They're all pending, so we'll wait for another work. Okay, and it added another 5, so we'll see maybe GKE will be smart enough to provision larger nodes instead of launching. Okay, and another 5. Now I believe we have about 20. 1, 2, 3, 4, 5, 6. Yeah, that's about 20 nodes. So we'll wait till new nodes appear, and this will conclude the demo. I'm just curious to see if it will keep launching the smaller nodes or... Okay, yeah, you see they're on the same node pool. So yeah, it just decides not to do the smart thing, just keep launching nodes that it will utilize only 60%. In my last night demos, I actually managed him to launch larger nodes with 4 CPUs, so it could pack three workloads on each. The next thing I'll do, I'll stop my workload, but we can see that we are provisioning more replicas, and the load is climbing, and we provisioning more replicas, etc. Now I will stop my workload, and within several minutes, we'll see that Autoscaler will see that the load is down, so it will remove all the replicas, and GKE Autopilot will see it has lots of unused nodes, so it will remove the nodes, and it will call it a day. So that concludes the demo. And I would like to know, how do you like Autopilot so far? Maybe everyone is asleep and... okay. Okay. Not too fascinating. Okay. I'll make sure to pass it to Google. It's either my demo is not convincing or the product is too raw. Let's wait a couple of more seconds. Going once, going twice. Oh, thank you. Yeah, the load is probably starting to, looks like it's starting to drop here. Yeah, let's revisit it in a couple of minutes. Okay, thanks for all who voted. So again, to recap, we have GKE Standard that's been here for 6 years, I reckon. You pay per VMs. You will require some Kubernetes skills to do all the customization that you want. There are several operating systems that's supported by Google. So you have Container Optimized OS, which is a fork of CoreOS/Chrome OS. You have various Ubuntus, you have Debian, I think, and you have Windows nodes. If that's your thing, then Windows workloads are supported. Security, and by security, I mean shielded VMs or workload identities. They can be turned on and off, and you can kind of control the Kubernetes version. So you can select Kubernetes version during cluster creation and keep it for some time. Eventually, GKE will force you to update, but still you have much more control about particular Kubernetes version. With Autopilot, on the other hand, you pay per pods. It will require, it requires basic Kubernetes skills. You basically don't need to think about like the DevOps side of Kubernetes configuration. You only think about the application side. The operating system is container optimized OS only. All the security features are enabled by default. Interesting fact that GCP actually provides you with SLA for pods. So if you run at least one replica of a pod in each zone, meaning you don't imply any tricks to make sure they all collocated like in a single zone and there is an outage, GCP will actually chip in to reimburse the costs. However, they take, with that automation, they take a lot of power away from you, so you don't have root access to your nodes, so you cannot install certain agents for third-party monitoring tools. Many add-ons as Calico or Istio are not supported. You can't use preemptible VMs. Like, not that you care, but I would say, pay per pod. But if I want to pay per pod on preemptible VM, give me a discount. The thing is not there yet. Again, it's fair to say that this product has been released only in February, and they improve things all the time. So I think it will improve in the future. Let's look at our setup again. You see the load has dropped to 0. So soon all these replicas will be terminated. Let's keep watching them. And now I want to briefly talk about Cloud Run, and I'll explain while I bring it here. So Cloud Run is a proper serverless framework, right? You think even less about infrastructure and more about applications. So if again I go back and map our application development pipeline to Cloud Run, so basically you have an application, you do the same thing as with Kubernetes in that you package it as a Docker image, and then you can create containers from the Docker, and that Cloud Run will take the Docker image and create one or many, however, as much as required containers, and give you HTTP service URL, which you can use to access those containers. And Cloud Run will take care of all the scaling, making sure they're alive, restarting, logging, and etc. So the similarity, and the reason I bring it is because you still have containers. So again, the first part of how you build your application, how you package it, it's the same with Kubernetes, and from there you can choose whether you go with Cloud Run or with Kubernetes. So Cloud Run is serverless for containers, right? You can have container and you have a system that manage a bunch of containers for you. You don't need to think in terms of pods or replicas or everything. You just have services that have a container image behind them, and Cloud Run takes care of the scaling. Now, as true serverless framework, You don't pay for VMs, you don't pay for containers, you only pay for resources that your containers use while they handle requests, right? So whilst your container is up in the air by Cloud Run and doing something, and by doing something, I mean it handles requests, you pay for the resources that that container uses. So when you launch Cloud Run service, you say, this is my Nginx, it uses 1 CPU and 1 GB of RAM, it costs X dollars per hour, and while your container handles requests, you'll pay for that CPU and RAM. And it kind of reminds the Cloud Functions model. The main difference is here that the whole container is up and it can handle multiple requests. So you define for every service the concurrency level. So by default, I think it's 80. So you have one container that handles multiple requests and it's up in the air, and as more requests coming in, it will keep handling them. It's not one function instance per request. So in this case, if you have a good concurrency handling in your application, it can actually be much cheaper than Cloud Functions. And of course, because Google bills you for the work itself, it has to pick in on what's going on. So it's event-driven, it's HTTPS, only WebSockets are supported, and of course it's stateless because Cloud Run completely manages the life cycle of your container. Even when it leaves it in the air, like for the next request, it's throttled. So your container is either dead. When your container doesn't handle any requests, it's either dead or throttled to 0. So there is no way you can do any background jobs. Again, it's all bundled to context of handling a particular requests. The interesting fact that it's built on Knative, so it's like an open source project, and you can deploy Knative on any Kubernetes cluster, and then if you develop your application as a Knative project, theoretically you can move it between different Kubernetes cluster. I haven't done it myself, so can't comment on that. The Cloud Run itself has very good GCP integration. You can route pub/sub events into the Cloud Run. It supports recently released cloud events thing, where you can basically react to events happening in your cloud. Like someone has created VM, so you can create a trigger that listens to that fact and sends a notification that a new VM is created. It enforces you to take care of authentication from the start, and of course it provides all the log collection and error reporting. And on the bright side, and again the reason I'm bringing it here, it's just a container, so whatever container you build, you can actually run as a Cloud Run. Sorry, whatever container that has HTTP server on that, you can use on Cloud Run /Knative. So it's still kind of related to that container/Kubernetes ecosystem. And this is my personal choice funnel. When I start a new project, I see, well, can I fit it into Cloud Run? Is it a good fit? Then I'll go with it, because it's really peace of mind. You don't need to think. It scales to 0. If your application is not running, then you're not paying a thing. And the next options are more expensive. So from there, it's like full Kubernetes thing. Either VM, you pay for VMs or pay for pods. But I first try to squeeze it into Cloud Run if it's a good fit. And if it's not, I'll go with the Kubernetes. Again, I'll consider Autopilot, particularly if I have teams that experiment in these things, and I want to be easy on infrastructure side on them. So yeah, this is the good thing to consider in my school. This concludes my presentation. Before we go to questions, we'll see that Autoscaler already killed all the replicas, and Autopilot will shut down the majority of those nodes pretty soon. Let's see if we have any questions. 5 questions. Okay, how do I make Autopilot cluster in AWS? AWS has similar product called Fargate. So you have Fargate with ECS, which is Elastic Container Service, and you have Fargate with EKS, which is Elastic Kubernetes Service. Take those two, it roughly resembles Autopilot. let me know if you want to elaborate on that. So again, the EKS plus Fargate is your Autopilot edition on AWS. Let's mark it as complete. GPU support, very simple. No GPU support at this stage, as far as I checked. I'm quite sure it's on roadmap somewhere, but currently there is no GPU support. If you have any particular use case or big workload that you consider, please reach out, and I want to connect you with custom engineering team and Google. It's, again, this product just recently released, and they seem to be quite interested in understanding the new use cases that come for it. Tick, if I have an app that requires 50 pods and half a gigabyte memory each, should I ask for 50? Okay. Well, I don't understand the question fully. You're talking about Autopilot. If you're talking about Autopilot, then you just request as much as you need for your pod. I guess here you're not talking about Autopilot, so maybe you can elaborate in chat on what you mean exactly, and we can take it from there. I'll focus on this question in the meanwhile. What's your opinion on Kubernetes? Not that good engineers to run production code. Oh, okay. So things are getting okay. Oh, sorry, it jumps here on most upvoted questions. Sorry. Okay. So I'll be always focusing on the top question. Since Cloud Run and stateless, have you had any experience with using Cloud Run for an application that requires state? Well, Cloud Run itself is stateless, and you have all databases solutions that you want to store your state. And yes, of course, you can use any of GCP databases. You can use Redis, Firestore, Cloud SQL. Of course, you need to provision them separately, but you definitely can. So Cloud Run gives you just compute part, not the storage part. You also cannot attach any persistent storage to Cloud Run containers. So it's basically the business logic itself, and it relies on external persistent layers that you need to have, and you have plenty of options, again, because it runs with a service account attached, so you can natively grant access to cloud storage bucket or Firestore authentication. So it's more in a Kubernetes, in GCP ecosystem. So there is a bit of vendor lock-in here, and I didn't develop on native Knative, pun intended. But yeah, and with all that said, I mean, it's still, I encourage you to evaluate Cloud Run for applications that require integration with other services. Let's say you have a support ticket created, you want to react on that to grant permissions. Yeah, this is like a perfect fit to run those business logic units. I find it very useful. And again, I prefer it, let's say, on Cloud Functions, because I can run, Docker images that I can easily test locally without residing to vendor-specific Cloud Function emulators that need to support my particular runtime. I want to use a certain version of Python that may or may not support it by Cloud Function. Because it's a container, I can use whatever tech I want, as long as it has a web server. I hope this answers the question. What are the use cases where Autopilot is good fit and where it isn't? If the more dynamic your workloads are, the more I would suggest using Autopilot. If your workloads are static, for example, if you host Elasticsearch database on Kubernetes, then chances are it's quite static. You have 10 nodes, big nodes that are there all the time. So with Autopilot, you'll be overpaying big time. On the other hand, if your workloads are dynamic, if you have things like cron job, if you have sporadic spikes, it will, I think, Autopilot is a good use case because it will save you of fiddling and testing your own auto-scaling scenarios. So yes, you can configure node auto-provisioning and node auto-scaling, but then you need to test this. You need to make sure it actually works. You need to see if it withstands your anticipated load spikes. And with Autopilot, you kind of delegate it to GCP, and chances are you will save money, but you'll save time for sure. Let's dig it off. Okay, I'll leave it for later. And let's focus on the second line here. What's your opinion on Kubernetes that lets not that good engineers to write production code and less consider of multi-threading and app stability? Well, the hard truth is, from my experience of developing software for 20-something years, is you always have those not that good engineers, and they will always write code. There is just no way around it, right? It's a very subjective thing, and the code will be there. I think Kubernetes actually gives a good give a good framework, as in boundaries to blast radius, right? So if you write the code that crashes, it will be restarted. If it crashes in loop, it will not, it will start to back off. So it will not keep restarting it forever and taking all CPU usage for a particular VM. So it provides those safeguards. It also provides you visibility that something is wrong with your application, so it can jump in. And the upside of that is also it also gives, again, hate prejudices, but say like good engineers of thinking too much. What happens if something, for corner case scenarios? So actually over the years I adopted that if I don't know what to do, let's just crash and count that it be restarted, right? It protects you from memory leaks, and sometimes memory leaks are really, really hard to debug. But with Kubernetes, you say, okay, I may have memory leak. That happens if my application runs at a certain load for a week. It will take an inhuman amount of errors to debug, but it's not too bad. I know I have a limit. When I had that limit, it's container level limit, so the pod will be killed and restarted. It will not require it will not cause stop of the world effect on the whole VM, so it will not affect my workloads. Yeah, that's life. You can't fix all the bugs, so you have an infrastructure that can help you to live with those bugs. And maybe those weeks that you would have spent it on debugging the memory leak, you would spend to write the next version of the app, so your bug will be obsolete in some time. And in the meanwhile, Kubernetes help you to live through it. That's my opinion, at least. Well, hope it helps. What's the average CPU scope? The cluster evaluator. I'm not sure I understand. Let me help in the chat. Maybe you can elaborate in the chat. With cold starts and Cloud Run, is there a way to speed up the scales? Yes, excellent question. Cold starts can be a big problem. So I advise you to optimize for quick starts and actually go through your code and see if you can make it start better. The second thing with Cloud Run, not so long ago, they introduced minimal instance count. So you can actually configure a service to have 1, 2, or 3, or as much as you like, instances that are up all the time. So this is kind of a warm-up thing. So whenever a request comes in, there is instance, it hits instance that's already up. And I recently read a blog post by some guy that said it reduced their startup latencies big times. Of course, you pay for it. One instance with, I think, quarter CPU and half GB RAM will cost you $20-something to keep up in the year. But it's compared to the price of having a spare VM on the side that will do the same thing. So it kind of makes sense, from an economical point of view. Yeah, it sounds expensive when you see the number, in the vacuum, but if you consider it to the amount of latency it reduces and probably your whole bill, that's not too bad. So again, Google Cloud Run, minimum number of instances, and hopefully it will say your cold starts issues. Let's take it off. Now, whoever wrote this question, I'll appreciate if you elaborate on what you meant here in the Google Meet chat. And I'll try to once again understand the first question. So I think you're asking about node optimization for GKE Standard. And yes, of course, the larger your nodes are, the more efficient it would be. So yeah, when you have large nodes, you can pack more containers on that on average. So the question is, yes, of course, request 5 10 GB RAM nodes than 51 GB RAM nodes. Yeah, because the kind of Kubernetes fee of that of system agents is fixed, regardless of the node size. So the larger nodes are, the more usable capacity you have on them. So I think we can tick it off. And if the person who wrote this question is still here, I'll appreciate to elaborate on the question. Thank you all. That was quite a long, but thank you for questions and thank you for